Hi there and welcome. My name is Dag and I am a senior compositor based in Berlin, Germany. Today I would like to talk to you about CG grading setups, and when I say CG setups, I really do mean to emphasize the word setups, because this is not a tutorial for a detailed technical investigation of the CG passes or AOVs themselves, nor will it be an in-depth guide on how to grade your CG or how to integrate CG into your plates, for example. What I will do, though, is to walk you through various methods for how to reconstruct your rendered beauty using the AOVs available to you in ways that allows you to grade that render in an efficient and flexible manner. Specifically, we'll have to look at 4 different ways of doing this, and we'll go through them, starting with the simpler setups, and then move on to the more complex setups. The 4 methods we'll have a look at will be, number 1, the simple additive method, number 2, the simple subtractive method, number 3, what I've called the combined additive and subtractive method, and number 4, the divide and multiply method. The last of those is a method I've used extensively over the last couple of years and is a way of doing things that might be a bit more novel to you, or at least to a lot of you, than the other 3. Please bear in mind that this is a long-form tutorial and not a quick fix. There are primarily 2 reasons for this. Number 1 is that first we'll be looking at 4 different ways of setting things up, and I will talk about pros and cons with all of these methods, and that's going to take some time. And the second reason is that the way I've chosen to do this is that I will, for all the methods, first introduce you to a version of the setup that I've seen in actual productions, and I've specifically chosen setups that are not optimal or might even have technical flaws within them, because this will give us the opportunity to discuss various things like do's and don'ts, what to avoid, etc., and hopefully give us a bit more in-depth knowledge than what would have been possible if I had just shown you the finalized versions of the 4 methods. So that will also take a bit of time, of course, but there should be a decent amount of valuable information that you can absorb and use in your own practice later, especially if you're not already super familiar with how to correctly set things up for grading CG. And by the way, of course, I will also show you a corrected or improved version of each setup in the end of each video. Okay, so how to do this then? The structure I settled on is as follows. I will divide the tutorial into several videos, starting with the one you're watching right now. So let's talk about this video first. In this video, we will first have a quick look at the render that we'll be using for our grading setups. Then I'll give a fast run through of some basics, like what the word AOV even means, and what kinds of AOVs there are, etc. After this, I will establish some ground rules or guidelines for how we should approach setting things up in the first place. This is good to have in general in the back of our mind so that we can approach the setup process in a more structured way. The final thing that I'll mention in this video is the concept of what I chose to call an AOV set, which is basically a look at not so much what constitutes each specific individual AOV, but rather that certain AOVs are meant to be combined with each other, and this is because they have been split out into AOVs during the rendering process based on the same criteria, for the lack of a better word. By the way, just so you know, I will be using the terms render pass, or just pass, and AOV interchangeably in this tutorial, because for all intents and purposes, at least in a practical sense related to this tutorial, they are the same thing. So that's this video then. In the second video, we'll look at the first setup, the simple additive setup. Then, in the third video, we'll go through the simple subtractive setup. Next video after that, we'll potentially have a very quick look at a bad way to use the simple additive setup. Before we then, in the 5th one, we'll go through the combined additive and subtractive method. And then in the final video, we will go through the divide and multiply setup before we say farewell for now. So much for the whole structure of the tutorial then. Let us just progress to the first things to cover, starting with the render itself. So here we are in Nuke, which will be our program of choice, of course, and we're looking at the render that we'll be working with for the duration of this tutorial. The scene here is a mix of some old scans of myself that I had lying around and a number of objects, so you can see all around here, that I've downloaded from Quixel, where I have a subscription. You can see that it's a still life of sorts. It's not going to win us any art awards, of course, but that's obviously not our intention. The intention is to cover the needs for this tutorial, meaning that we have to have enough AOV passes to facilitate the setups that I plan to showcase. To enable that, I created a scene in Houdini that have lots of different surfaces, shaders and colors in general, so that we have information for many different AOVs. Now, if we look at the drop-down over here, you can basically see that we have a bunch of AOVs in the current data stream. And you can also see from their names here, if you can have a look to the left, you can see the naming conventions that Houdini's native renderer called Karma uses for these passes out of the box. Now, other renderers will of course have slightly different names for the same data. Okay, so what else is there to mention? Well, the image is a single multi-channel EXR file, since I don't really need more than one frame for this demonstration, and keeping most AOVs inside just a couple of files seemed like an economical way to go about things for this tutorial. And furthermore, it has been rendered in ACES CG color space. Also, the passes I've output from Karma, which is the renderer that I did use, are only easy to access passes. I've not output any, in inverted commas, more specialized AOVs like, for example, raw lighting. I'm sticking to very straightforward AOVs for this demonstration. And finally, I can quickly show you that I've made two versions of the same renderer. So if you go in here, you can see down here, I can switch between these two. And basically, I have one render that you can see up here that has a kind of a backdrop in the back. And if I turn the switch node on here to 1, you can see I've got one without it, which means I have one render where we have an alpha channel where we have the option to see actual edges of objects in the foreground. And if I switch this back, we just have a white alpha. And you'll see why I did this once we get into the actual setups. And over here, I have a second render that basically just have some utility passes and things in it. Okay, I think that's it for the render file for now. Let's get into some basic information about the AOVs themselves. I know I said that I won't go into detail regarding what the different AOVs are and so on, because really that's not what this video is about. But nonetheless, I do think I at least have to do a quick run through the basics of what AOVs are before we move on. So AOV is short for arbitrary output variable. And what they do is that they describe per pixel information of a CG render. And each AOV will contain, therefore, some data that describes some aspect of the CG scene in front of the camera. And there are a few different types. And I guess the common types are the, number one, the additive AOVs, as they are most often referred to, at least that's basically the name that I've been used to for some time now. These are the AOVs we're going to use to rebuild the actual beauty. So I guess you can say that the additive AOVs represent partial information of the actual beauty in such a way that when you add them, or when you plus all the needed AOVs together, the resulting image will be the same as the beauty. In other words, they are used for reconstructing the beauty. Then we've got utility AOVs, and they will be AOVs that describe aspects of the scene that are not part of the beauty. So basically not the kind of pretty picture stuff, but rather things such as your scene depth, normals on your objects, positions, etc. And sometimes the utility AOVs will be called data passes. Then we have cryptomats, which are specialized AOVs for masking objects in your scene by the materials or their object IDs, etc. And we also have deep. I'm not sure if you can call that a classic AOV, but I'm going to include it here anyways. And deep, well, deep renders are for deep compositing, which is a subject we're not really going to touch on at all in this course, so I'm not going to say too much more about that. Okay, so we have our image, we've got the AOVs that we need, and now the obvious question is, of course, how do we build a good CG setup for the grading that we're planning to do? And also, when we're doing this, what should be the things to focus on when we're doing it? So for this, I decided to set up some ground rules, some requirements really, where the first rule will be that the result of the AOVs that are combined to reconstruct the beauty, they need to be exactly the same as the actual beauty. That's going to be the first rule. The second rule is that any combination of AOV passes that the renderer is going to give you that belongs to the same set of AOVs and that can be combined to satisfy the first rule that we have will count as a valid combination of AOVs. If the combination of AOVs will not satisfy rule 1, then they are not valid for the setup. The third rule is that grading of AOVs, we should do that in an unpre-multiplied state. So we need to keep that in mind as well. This is when things like your alpha channel is going to come into play. Then we have rule number 4. The setup should be constructed with a kind of visual clarity in mind, meaning that we ought to build it in such a way that it is easily readable to anyone, not just to ourselves, because of course we're the masters of our own setup and we know exactly how it functions, but we also should pay attention to construct it in such a way that other people will easily understand the setup as well. The fifth rule will be that we're going to try to keep the data sparse whenever possible. By that I mean that we're going to kill passes or kill information in the data stream when they're no longer really needed for the setup. And there are cases where you can do this, there are cases where you cannot do this, and maybe even cases where you might not want to do this. But for our purposes, we should at least try to minimize the data when we can. Then we have a sixth rule, and that is that we are going to try to stick to the general design principle or the general architecture of nuke, where the B pipe of any node is the main pipe through which data flows, so we need to pay attention to that, and that data, generally speaking, flows from the top of a setup towards the bottom. So if you look at any node in nuke, mostly you have an input at the top and an output at the bottom. So with that in mind, we're going to go for a predominantly top-down type of setup. You can build it differently, of course, but that's what we're going to do in this video. And I guess you can say as well that the first three rules on our list are kind of more strict rules, when the last three rules are more like guidelines, I think. Okay, so I mentioned the word set or AOV set earlier. You might wonder what exactly I mean by that. Well, what I mean is that any modern renderer can output lots of additive passes, but those passes are not meant to be added together in any given arbitrary combination. Instead, there are groups of AOVs that are meant to be combined, and therefore, of course, are not meant to be combined with AOVs from other such groups. And it is these groups that I will refer to as AOV sets in this tutorial. You can say that an AOV set is a group of AOVs that are output or split out during the rendering phase according to some given specific criteria. And each AOV set will let you reconstruct the beauty independent of other such sets. And here we will be talking about and using three such AOV sets that are very common in practice. The terms that I will be using for these three sets will be as follows. First, we have the material AOV set, or material AOVs. A material AOV describes a particular given surface quality in a given rendered object in your scene. So in other words, how the surfaces of the objects in your scene respond to the light that hits them. For example, is it a very reflective surface? Is it a diffuse kind of surface? Is it transparent or semi-transparent, etc.? And we can quickly check that out by comparing the reflection AOV with a diffuse AOV, for example. So let's do that. As the name of this AOV implies, we have here all the reflections in our scene represented in one AOV. And we can clearly see what constitutes reflective properties in general versus what constitutes diffuse properties in general if we switch to the diffuse AOV. We can also see how the objects themselves differ from one another in how reflective or how diffuse they are overall, as well as how these properties manifest themselves in any given surface specifically. So for example, this is purely reflective, and this here is much more diffuse, and there are differences in degree and quality of how the diffuse looks like, in between these objects themselves. And the second AOV set, or the second groups of AOVs, will be the light group AOVs. Light group AOVs represent the contribution of any given light or groups of lights in your scene. Imagine this following scenario. You're standing in a dark room with a flashlight in your hand, and you turn the light on. And now you can, of course, see the room. How the room looks to you will depend on where you put your flashlight, how strong it is, and so on. Next, imagine you turn the lamp in the ceiling on, and naturally the room now becomes much brighter because you've added a lot of light into the room, but you can still move the flashlight around the room and see that the contribution of that light is different and separate from the ceiling lamp. And in a sense, this is what the light group AOVs are about. The ability to separate out the lighting of a scene by the lights adding illumination into it. So if we check out the high key light AOV, we can see that the image gets darker because we're now only looking at the contribution of one light. And we can see that this AOV has reflective components, as well as diffuse components, and transparent components. So this is effectively kind of like a quasi-beauty pass, but for one light only. And yes, you can actually break down this kind of AOV even further, but we will not do this for this kind of AOV in this tutorial. The third term, or third AOV set, will be the direct and indirect light contribution AOVs. They are essentially material AOVs as well, except that they have been further partitioned into representing either the direct illumination portion of a given AOV or the indirect illumination portion of the same given AOV. Therefore, I have chosen to not lump them in with the material AOVs, but rather describe them as a separate set in order to make the point that we are dealing with AOVs that find their specificity more in the type of light contribution we are talking about in that scene. So a good example would then be to look at the reflections again. In the combined reflections, we see the sum total of all reflections in our scene. And it's not too difficult to see that we have some reflections that are the result of the light hitting a surface and then reflects off of it so the camera can see it, and that we have some reflections that are the result of bounced light from other surfaces, such as the tabletop. So light first hits the table, then the object, and then off of that into the camera so the camera can see it. And when these attributes come as separate AOVs is when I will be talking about the direct and indirect light contribution AOVs. And you can clearly see that from these passes here. So if we switch from the combined glossy reflection to the direct glossy reflection, you can see that the bounced light disappeared. So now we only have the direct portion. And obviously, if we switch again to the indirect glossy reflections, we now only have the bounced light in our scene. Right, so that then is a fast run-through of the 3 AOV sets that we will be dealing with in this tutorial. One thing to note is that we will be using just very standard AOVs for our setups. There are of course more specialized AOVs like albedo passes, shadow passes, raw lighting AOVs, etc., that can be used when rebuilding your beauty, but we are not going to use these more specialized AOVs here. We're going to stick to more standard AOVs, in essence, the ones that you are most likely to encounter on a daily basis, I think. And with that, I think we have more than enough information to jump into the next video where we will be dealing with our first setup method, the simple additive method.